So when I say Hadoop framework, there are two main components in Hadoop, right? So Hadoop has storage component and there is a processing component. I mean, Hadoop has this HDFS and then MapReduce. HDFS is the file system component and MapReduce is the processing component. So what is HDFS? I mean, when we saw this big data problem, the first problem is volume. When there is an increase in volume, you couldn't able to store that in a traditional database. So the first problem is to store somewhere. Okay. Store a large amount of data without worrying about will it exceed the limit? Will it exceed? I mean, you do not have control on the data growth, and you want to store somewhere, form a data lake. HDFS is the storage layer for such thing. I mean, you have this file system, right? Generally, I mean, you have in one machine you have a file system, which is a Linux file system, which is based off, which is like, you know, a native file system in which you create directories, you put the file, and all that is there. This is restricted to one machine. With HDFS, it is a file system that sits on the top of your native file system, but spread across multiple machines. I mean, if you just imagine, like, you know, the file system is something which is like a river just passing across multiple machines, or a ring that is connecting multiple nodes or multiple machines. So when you put a file, the file is split and then kept it in multiple machines, right? So that is HDFS. So I will go in detail about it first. But typically, cluster would be, you know, I mean, this is with respect to Hadoop 1.0. There are different versions to it. There are Hadoop 2.0 version is there. I just want to cover initially with Hadoop 1.0. So some of the things which you see here is actually, you know, better improved, better in Hadoop 2.0. I mean, for example, the number of servers that you can actually, number of nodes or servers that you can put it in Hadoop framework is limited to 4,000, but in Hadoop 2.0 it is much more. And moreover, you know, if we want to define Hadoop as a Hadoop framework, right? I can say that it is actually a framework first. I mean, when I say framework, it is actually it has different components and which is developed in Java. It's basically a Java application. It's a framework. Next, it is used for storing large volume of data and also processing the same. So that is where HDFS and MapReduce comes. And how does it do this, right? It's actually do that in a distributed way. I mean, data is split split and kept in multiple machines, and then stored there, and then the processing also happens in multiple nodes. But how it is getting stored, and what all the strategy with respect to processing the data in different machines, all that we will discuss. But a typical definition is it's a framework used for storing large volume of data and also processing large volume of data and distributed in multiple machines. Okay. I mean, data is distributed in multiple machines. Okay. In typical cluster, I mean, as I said, it's 1.0, 4,000. Now it can be increased like 60,000 and all. You can each server configuration can be like this, as you're seeing here, like 2 quad core and 16 to 24 GB RAM and 4 to 12 TB disk space and 20-30 servers per rack. I mean, rack. I mean, you would have seen that, right? I mean, rack is like you would have 3 racks and 20-30 servers or boxes will be there within each rack. And moreover, you know, the term here says commodity server. Commodity servers are something they call it as carrier class servers. which is not very high-end servers like typically you would use in traditional systems. There is something called scale-up architecture and scale-out architecture. In traditional systems, if you have to increase the infrastructure, then you would go for high-end servers. That is called scale-up architecture, and you can always, that is not feasible in a way. You can't always have this budget of buying a new server every time, right? Whenever the data grows or whenever you need to increase infrastructure and all that. But here what happens in Hadoop is it's called scale-out architecture. In a way, if the data growth happens more, then you can add nodes or machines to the cluster. So this is called scale-out architecture. And one other advantage of Hadoop is, as I said, it's open source. It can just use commodity servers. Commodity servers are not high-end servers. You can go with carrier class servers of this configuration, something which is showing here. So the budget, when you think of to have such infrastructure, is compared to have high-end servers is quite less. And so, as I said, it is actually a cluster, right? A cluster group of nodes. That's where Hadoop framework runs. And when I say cluster is a group of nodes, and you will have number of nodes or number of machines there connected put it in a rack, connected through network. So there are two types of nodes. You'll have like master nodes, and you'll have something as slave nodes. Master node. What are the master nodes? If you see, as I'm just saying, showing it here, there are two nodes which are master nodes, which is NameNode and the job tracker. What is NameNode and job tracker? And these are all the services which will be running in a specific machine. If a machine is running certain service, then you call the machine as by that name. For example, if I'm running NameNode service, just like think of any of the services in your machine, right? You will have your antivirus service running. You will have Windows application service running. So when something like that, Hadoop has certain services or daemons like a NameNode service, job tracker service, and data node service, and all that is there. When a machine is running NameNode service, you call that node or the machine as NameNode. When a machine is running job tracker service, we will call that machine as a job tracker node, right? That's the master node. But what is NameNode or what is job tracker? I will come to that. So when you actually place a file in Hadoop framework, typically you would have a external node. There will be a node called a client node or edge node, which will have the configuration about different settings. I'll come to that. But typically what happens is when you actually put a file through client node, which actually takes the file and put it in cluster or in Hadoop nodes, it actually divides the file in 64 MB block. It's Hadoop 1.0. In Hadoop 2.0, it is 128 MB block. So a file is split into MB blocks and then kept in multiple machines. Right, and when it kept in multiple machines, NameNode is something which will have this information of what blocks has gone to what node and what is the directory structure. When you create a directory in Hadoop file system, and when you actually push the file to Hadoop file system, it will know under which directory what block is stored and whether which node. Such a metadata information will be stored in NameNode. It is actually one per cluster. In Hadoop 1.0 and 2.0, you have something like standby node and all. I will discuss later. So you got it. But the NameNode is something which is used to store the metadata about the blocks of the file, where it's stored. That information will be there. If you think of, you take a book. If we take book as an example, you have this index page, which is having the topic name and the page number. Think of master node as something which is having this information, right? Which is having the complete metadata information. And there is something called secondary name node. Secondary name node is used for checkpointing at any time to save the state of the name node, so that it can be restored when there is a failure happens. And then you have job tracker. Job tracker is specific to processing the data in Hadoop. Okay, I will come to that a little later. And you have slave nodes. Slave nodes are nothing but data nodes. I mean, data nodes are the machines or the nodes which will actually have the data. When you put a file in Hadoop file system, the data is stored in data nodes. The metadata about where it is stored will be stored in name node. Name node will be, there will be only one name node or one more name node, two name nodes in case of failure, but there will be other nodes will be data nodes only. Other nodes will be data nodes. And then, I mean, the data nodes are the machines in which the data will be stored in blocks. And task trackers are something which are specific to processing the data in Hadoop file system. Task trackers and job tracker and task tracker are something which is used for processing the data. Assume that you have kept a file there in Hadoop file system and the file is kept in multiple data nodes. Now you want to do simple transformation work, or simply want to do count of the words in each of the block that is stored across the Hadoop. So what happens is you would have a program which will be reading a line and then getting the count of each of the terms in every block, right, across the nodes in cluster. So job tracker is something through which you will be submitting the job. The job tracker will take the code and push the code to all the data nodes. And task tracker is something which will be running in the data node mission. I mean, when I say data node, there is a data node service running in a specific node. Data node or service will be there, and it will also having task tracker services. This is task tracker service and data node service will be there in the same mission. In any mission, when you say data node, when you designate there's a data node, it would also have task tracker service running there. So when you actually pass the program through job tracker, I mean, the program is going to do some process on the data. The program will be executed by the task tracker, and task tracker will send the information about the progress of the task back to job tracker, saying this is completed, this is in progress, and all that is there. It all happens through a kind of heartbeat signal.